Have you ever looked at a modern factory, with all the robotic arms, conveyor belts, and machines moving in perfect sync, and wondered, how on earth does all that work together? Well, it's not magic. It's more like a symphony of code and engineering. And today, we're going to look at the conductor's baton for that whole symphony. I mean, that's the fundamental question in modern industry, right? You've got dozens of different devices, sometimes from different companies, and they all need to speak the exact same language to build a car or bottle your favorite drink. So how do you get them all on the same page?
Probably the best way to think about it is something we all have in our pockets. Just like an OS makes your phone's camera, its GPS, and all your apps work together, a special industrial platform does the same thing for machines on a factory floor. And that's exactly what we're diving into.
So this idea of a unified platform, this operating system, is what makes all today's crazy automation possible. It's basically the brain and the central nervous system for the entire production line, all in one place.
Okay, so let's put a name to it. The system we're talking about is Siemens TIA Portal. And that TI part, it stands for Totally Integrated Automation, which honestly pretty much says it all.
See, back in the day, an engineer needed one piece of software for the main controller, a completely different one for the operator's touchscreen, and, guessed it, another one for the motors. It was a mess and super inefficient. TIA Portal just brings all of that programming and configuration under one single roof, inside one single project file.
And this slide really shows you what's packed inside that one environment. You've got step 7, which is the brains of the operation. It programs the PLC. That's the rugged computer running all the logic. Then there's WinCC, which lets you design the touchscreens the operators use. You've got Start Drive for setting up all the motors. And, this is a big one, Safety Integrated, which lets you build things like emergency stop systems right into the main program.
So what does all that integration actually get you? Well, because everything is sharing the same data, you just get rid of a ton of errors and headaches. And the results, get this. Siemens says engineers can cut their total development time by up to 30%. That is a massive, massive efficiency boost. Okay, so this isn't just some abstract software theory, right? This stuff is the backbone for some of the most advanced factories on the planet, making things that we all use and rely on every single day. Let's kick things off in one of the most complex places you can imagine, a car factory. And not just any car factory, but one building high-tech electric vehicles where every single movement has to be perfect. And here's the perfect example. For the production of the all-electric Porsche Taycan, TIA Portal is the conductor for all the sophisticated conveyors and robots that put the car together. This is where having that seamless integration isn't just nice, it's absolutely critical. All right, so from high-speed cars, let's jump to something completely different. Automation isn't just about going faster, it's also about finding new, more sustainable ways to make things. The Finnish company Spinnova, for example, uses TIA Portal to control this incredible new process. They're turning wood pulp into textile fiber using 98% less water and no harmful chemicals compared to making cotton. There's just no way you could achieve that level of control without a really powerful integrated platform. And the impact goes even deeper, into systems that, we all depend on for daily life, like making sure our water is clean and even developing the energy sources of the future. TIA Portal is running everything from city water systems to the super precise filtration needed to produce green hydrogen fuel. To make that clean energy, you need water that is unbelievably pure, and this is the kind of automation that guarantees you hit that standard every single time. But, having this much power packed into a single tool, well, it's not always a walk in the park. For the engineers who are in the trenches with TIA Portal every day, its complexity creates some pretty big hurdles. So let's break down the 4 biggest headaches they run into. We're talking about the sheer computing power you need to run it, the nightmare of juggling different project versions, how tough it can be for new people to learn, and of course, the ever-present threat of cybersecurity. First up, hardware. This software is a beast. The official minimum for RAM is 16 gigs, but as you can see here, pretty much any engineer will tell you that you really need 32 gigs for it to run smoothly. Try it on anything less, and you're just going to be waiting around, which slows everything down. Okay, next is version management, and this is a huge one. As this slide shows, the software isn't really backwards compatible. You can't just open an old project. You have to permanently upgrade it. And to talk to a machine out on the factory floor, your software version has to match the machine's version exactly. For an engineer who has to service dozens of different sites, that is a major, major headache.
So, how do you get a handle on all this complexity? Well, the answer is to build and test everything in the virtual world first, before you even touch a single physical wire. This whole idea is called the digital twin. And the payoff is just staggering. By creating a simulation of the entire machine right inside TIA Portal, companies can test all their code in a safe virtual space. This is called virtual commissioning, and it can slash the time you spend testing on the real hardware by up to 50%.
And check this out. This is all about the money. Finding and fixing a bug in the code during that virtual phase is estimated to be up to 800 times cheaper than finding that same mistake after the machine is already built and sitting on the factory floor. That is an incredible saving. And the digital twin's job isn't done after the machine is built. Once the real thing is running, that virtual model can use live data to actually predict when maintenance is needed. This can lead to a 15% increase in uptime just by providing breakdowns before they happen. Now, the latest step in this evolution is where things get really wild. Siemens has now built a generative AI assistant right into TIA Portal. So an engineer can literally type a sentence in plain English, something like, create code to start a motor, and the AI just generates the code. It's a total game changer for development speed. And that, of course, brings us to our final big question. We've seen a platform that brings everything together, a virtual world that takes away physical risk, and now an AI that can literally write its own code. So as these tools get smarter and more autonomous, the role of the human engineer, well, it's going to change profoundly. What does that future look like? That's the question we're left with.